Okay, good morning. I'm making a video going over your homework. Your homework was to solve systems using matrices. So the first two problems ask you to solve just using inverses. So I'm going to do the first two. They aren't row reduction that you've learned today. Okay. Okay. All right, these systems of equations, why this is chapter 3, part 2 is because all of chapter 3 is solving systems. Matrices is its own beast, though, and a very intense process to solve a system, and that's why it's its own separate chapter. I've made it. So here we could solve the system using graphing, substitution, or elimination. We are using matrices, though. So you take the coefficients and you make them one matrix. Then you take the next matrix and you make it the coefficient, or I'm sorry, the variables, and it's equal to the results. So this is review. So we ask ourselves, how do we get this matrix by itself? We have to remove this matrix. Currently, it's being multiplied. How do you get rid of multiplication? Use division. With matrices, there's no division. There's only multiplication. So you use the inverse, the multiplicative inverse to get rid of it. So I'm going to call this matrix A. I'm going to call this matrix X, and this is matrix B. So how do you get rid of matrix A? I want A inverse. But what I do to one side, I have to do to the other. Well, we know what A times A inverse is going to be. It's just going to be 1, or the identity, 1, 0, 0, 1. So matrix X is just going to be whatever the inverse times matrix B is. So I don't have to show all the work. I just need to show enough work where it looks like a solutions manual. Okay. So I'm going to put in my calculator, second matrix A. I'm sorry, what am I doing? Second matrix, go over to edit A. And this is a 2 by 2 matrix. And my matrix is 1, -5, -4, and -2. We're going to go to second, quit, to get back to the home screen. Now I want the inverse. So I'm going to go to second matrix, and I'm not going to edit it. I'm going to use it. So I'm going to press enter. And then this little button right here is the inverse button. Enter. Okay, those are ugly decimals. I want to make them fractions, so I hit the math button. Fraction is already highlighted. I hit enter. I hit enter again. All right, so that's what I'm going to write down. So matrix X is 1 1/11, -5 over 22, -2 over 11, and -1 over 22. And I'm going to multiply that to the -5, 20. Okay, it matters. Order matters what side you're putting the inverse on. Well, I don't want to actually physically do all this, so I'm just setting it up, showing you. I'm going to do this again, but I need matrix B now in there. The calculator is actually going to do the work for me. So I'm going to go down to B, and that is this was a 2 by 2, so this is a 2 by 1. These have to be the same in order for it to work. So 2 by 1, and we're going to put in -5 and 20. Second quit to get out. Then we go to second matrix again. We're going to use matrix B. Okay, but I needed in front of it. Let's do second matrix. We needed A inverse, and then I'm going to use matrix B. So that's what I wrote on my paper. And what do we actually get? -5, 0. So matrix X is -5, 0. So you could say it like this, you could say it like this, or you could make it a coordinate. Okay, and substitute back in, does it work? -5 times 1 is -5, 0. Yep, it works. You could try it for both. right, that's what you're going to do for number 2. I'm not going to go over it. I just did an example of it. I'm just going to do one of each. Okay, let me click off the screen and find. Next problem is going to be using row reduction. We have 2x plus 2y equals 0, 4x minus y equals negative 20. And we're going to make an augmented matrix, meaning we're just using the coefficients and we're just using the results. The missing variables are assumed. So here are my coefficients. When you multiply, let's go back a step. When you multiply a matrix times its inverse, you're going to get the identity, 1, 0, 0, 1. Once you've received the identity, x is technically by itself. If I can somehow manipulate these numbers to be 1, 0, 0, 1, then I've theoretically solved. So if we want a number to get to a 1, we multiply. If we want the number to turn into a 0, we multiply the other row and add it to the row we're changing. So first step is we want this 2. We're going to go in a U-shaped pattern. We're going to create 1s to knock out the 4, and then make this a 1 to knock out a 2. So the first row is 1/2 row 1. So I'm going to change row 1 to be 1, 1, 0. I didn't change the second row. All right, that was the easy part. I want to turn this 4 into a 0, so I need a negative 4 to be added to it. I don't have a negative 4, but I'm going to borrow this row off to the side and multiply it by 4, and then I'm going to apply it to row 2, which will then be changed. So off to the side, I'm showing my work. If I multiply the first row by negative 4, it becomes negative 4, and 0. Well, what is row 2? 4, negative 1, negative 20. So I just borrowed the first row. I'm not changing it. I'm changing the second row. I borrowed the first row, made it negative 4, and I'm applying it to 4, which is going to become 0, negative 5, negative 20. All right, we're getting there. So this 1 was used to knock this out. We're going to create this to be a 1 to knock this out. So what do I multiply by? Negative 1/5, because we want it to become a 1, a positive 1. So if I'm just changing row 2, okay, I'm going to leave row 1 as it is. If I multiply negative 20 by negative 1/5, it becomes 4. Okay, so 1, 0, 1, what does this need to become? A 0. So we're going to make this row negative. We're going to borrow it. So negative row 2, and we're going to add it to row 1. So negative row 2 would be 0, negative 1, negative 4, and we're going to add it to row 1, which is 1, 1, 0. The result will be, well, we didn't change the second row. We're changing the first row. We're applying it to the first row. 1, 0, negative 4. So my solution is negative 4, 4. You can pause it, rewatch it. Here's the thing. We want to just make it perfect the first time around. We don't want to write a bunch of stuff. Well, guess what? You got to make a mess. Look how much paper I used for this one problem. That worksheet might not be enough for you, and that's fine. Do it on a separate sheet of paper. Check your work. When I substitute negative 4 and I get negative 8, plus 8 is 0. Yes. Take pride in your work. Make sure it's correct and be thorough. Okay? So I want you to try the other one on your own, and then in class, if you have questions, we can go over it again. Well, that's how you do a 2x2. Now, it's not required. You can use a calculator, but I would like you to be able to do a 3x3 on your own. Okay, so let me grab a sheet of paper. Let's do a 3x3. All right. Okay. So here's a 3 by 3 matrix. There was no y in the original problem, so I made it a 0. Be careful with that. We need to turn this into a 1, this into a 1, and this into a 1. And the rest have to be zeros because we're trying to get the identity. Because if you get to essentially 1, you've solved. And when you solved, you have your answers. So we're going to take this 1 to knock out these 2. Then we're going to make this a 1 to knock out these 2. Then we're going to make, well, you knock out this 1, and then this 1 will be affected later. So it kind of goes like this. Because then you want to create this a 1 to knock out that guy. And then you're going to knock out both of these, which were whatever ones you want. So let's get started. We're going to multiply this by negative 1/4. We're going to get 1, 0, 6/4, that's fine, and 12/4. Okay. Then this is going to become negative 6, negative 4, negative 2, 6. It didn't change, and neither did the last row. I'm going to reduce. I'll make this a 3. So I'll be writing pencil. And this is going to be 3/2. Take your time with it. Okay. Now that this is a 1, I want to get rid of this negative 6. So I need to make this 1 for the moment a positive 6, and then apply it to row 2. So the top row is going to be 6, 0, 18 over 2, which is 9. Math is beautiful. 6 times 3 is 18. Row 2 is negative 6, negative 4, negative 2, and 6. You're going to get 0, negative 4, 7, 24. Okay. It's going to be, the first one technically has not changed. We just borrowed it. The second row is what we applied. So it's going to be 0, negative 4, negative 2, and 6. The third row didn't change. Oops. All right. I'm sorry, this DocuCam goes in and out. That's why I tend to use my iPhone, because this constantly is refocusing. The bottom one should be a 0. So we already have a positive 1. Just add it to the bottom row and you're good. So take the first row and apply it to the last row and you're good. So this is going to be 1, 0, 3/2, 3, 0, negative 4, negative 2, and 6. When we apply it to row 3, it's going to be 0, 2. Well, 1 is going to be 3/3. I'm sorry, 2, 2, because it's over 2. It's going to be 5/2. And then when we add these two together, it's going to be 12. Okay. This one, we're going to multiply by negative 1/4. So I'm going to have 1, 0, 3/2, 3, 0, 2, 5/2, 12. The middle row is 0, 1, 1/2, negative 6/4. Okay. So we've taken that 1 and gotten all these zeros. Now we're going to take this 1 and make this a 0. you need to make this a -2 to cancel this. So -2 times row 2 plus row 3. If this is a lot right now, pause the video, okay? Rewind it, come back. Well, -2 to row 2 is 0, -2, -1, +12/4. Oh, -2 times this is +12/4, which is just 3. When you add it to row 3, that's 0, 2, 5 halves, 12. It's going to be, only changing row 3, it's going to be 1, 0, 3 halves, 3. Row 2 is 0, 1, 1 half, -6/4. And row 3 is now 0, 0, -1 is 2/2, so it gives you 3 halves. And then we add it, it's going to be 15. All right, now multiply this row. I need another sheet of paper. I don't know why I didn't have one. This one's going to be multiplied by 2/3. And it's going to be 1, 0, 3 halves, 3, 0, 1, 1 half, -6/4, 0, 0, 1. And that's going to be 30/3, which is 10. Okay. Now we're going to take this to knock this out, and we're going to knock it out up here. So we're going to take -1/2 to row 3 and add it to row 2. So it's 0, 0, -1/2, and then -5, and row 2 is 0, 1, 1 half, -3 halves. You can reduce it. When you add it together, it's going to be 0, 1, 0, and this is going to be 5, it's going to be 10/2. So it's going to be -13 halves. So you're going to get 0, 0, 1, 10, 0, 1, 0, -7.5. And then 1, 0, 3 halves, 3. I don't feel like that's right. But let's keep going. How do you get 3 halves? You need to multiply -3 halves. I'm sorry, how do you get 0? You need to multiply by -3 halves to get row 3. So it's going to be 0, 0, -3 halves, -30/2, which is -15, 1, 0, 3 halves, 3. So it's going to be 1, 0, 0, -12, 0, 1, 0, -7.5, 0, 0, 1, 10. Here's the thing. If you did the whole process right, but your answers are wrong, then I'll still give you points. If you can't find your wrong answer, but you find the right answer showing the calculator, then you're good. So how could you do it with a calculator? You'd say second matrix over to A, and you'd get a 3 by 3, and you'd say -4, 0, -6, -6, -4, -2, -1, 2, and 1. Second matrix A. Well, I need the other matrix. I need B, which is 12, 6, and 9. So it's a 3 by 1. It's -12, 6, and 9. So negative, it should be -3, 1, and 4. And that is not what we have. So if you did all this work, the process is right, but I probably just added incorrectly or did something. And if I say, well, actually the answer is -3, 1, and 4, I'll give you your points. Okay. All right. Any other ones you want to go over in class, we can. Like I said, the 3 by 3 isn't required because you can use your calculator.